I admire you for the fact that you make time. You actually make time to listen, learn, and grow. Please grab your pen, drop down the key points. I explored all I could, and I really want all of you to follow till the end of this video. You're automatically including a lot of wonderful progress in your preparation. And let's get into today's video, which is on homogeneous differential equation. And this topic is from differential equations of first order and first degree. So let's get started to solve dy by dx is equal to y plus x minus 2 by y minus x minus 4. So here is a logic that whenever you see the constants here, so you have to imagine that it is a non-homogeneous differential equation. I've told you about homogeneous differential equation where these constants are not there. If there are two constants, just transform it as a non-homogeneous differential equation. See here in the solution, so dy by dx can be written as, see here, first I'm writing the x term and next the y term, and this is minus 2, and here the x term is minus x, this is plus y, and this is minus 4. See, first of all we have to do one thing, that we have two methods here. The first thing is the quotient of x is 1 and the quotient of y is again 1. The quotient of x is minus 1 and the quotient of y is 1. So you have to make, this is a1, this is b1, this is a2, and this is b2. So make a determinant out of this. This is 1 into 1 minus, this is minus 1, which is plus 1. This is not equal to 0. When the determinant is not equal to 0, there is a small substitution that put small x value is equal to capital X plus h and small y is equal to capital Y plus k. So if you have dx, see here, this will be capital dx and small dy value will be, this value will be capital dy. So just you transform, you substitute all these values. So all these values, this is 2 and name it as this value is 1, and substitute all the values of 2 in 1. Substitute 2 in equation 1. See, then see what happens here. So dy by dx can be transformed as, small dy is transformed as capital dy and small dy is transformed as capital dy, and this as small dx can be transformed as dx, and this small x can be written as capital X plus h, and this one as capital Y plus k, and this one is minus 2 divided by, this is minus of, this is capital X plus h, and this is capital Y plus k, and this value is minus 4. Clear? And now let's get started to solve this. So here this is dy by dx value can be written as, this value is capital X and this value is capital Y, and this can be written as h plus k, and this is minus 2 divided by, this value is minus x and this value is plus y, and this is minus h plus k, and this value is minus 4. See here, just I am grabbing this one. So dy by dx, so dy by dx is equal to, so I'm taking this part, and this is a homogeneous differential equation. So these two are, name it as equation 3 and I'll solve later. And see here, this is a differential equation which is formed dy by dx value is equal to, this is x plus y by, this is minus x plus y. And now we got a different homogeneous differential equation, and therefore there is a substitution, put y is equal to, this value is vx, and now dy by dx value will be v plus, this value is x into, this is dv by, this value is dx. So this is the substitution which you have to substitute here. This is capital A and this is capital B. Substitute the values of capital B in capital A. See now what happens here. So in place of dy by dx I am writing, this is v plus, so this value is v plus x into, this is dv by this is dv by dx. So here for x it is 1, if I leave x this will be dv, so this value is dv by dx, which is equal to, so this value is x plus, in place of y I am keeping vx. Clear? And in this is minus x, and in place of y I am putting vx. See the next step what I am going to do, this is vx, and next in the next step what I am going to do is, I am going to take this x common and cancel. See here, this will be v plus, so this will be v plus x into dv by dx. dv by dx value is equal to, if I take x common, this will be 1 plus v, and if I take x common, this will be minus 1 plus v. So if I cancel these two and see, the next step what I'm going to do is I just transform this v to other side. So this will be x into, this value is dv by dx value is equal to, this is 1 plus v by minus 1 plus v, and this is minus v. So this value is x into, this value is dv by dx value is equal to, this is v minus 1. This value is 1 plus v. If I multiply, this will be v, and this is minus v square. So x into this value is dv by dx value is going to become 1 plus 2v minus v square by, this is v minus 1. Clear? Now variables and separables. I am separating the variables v to one side and x to one side. So this will be v minus 1 by, so this value is minus v square plus 2v plus 1 into dv value is equal to, this is dx by x. This value is dx by x. And see, now I'm integrating on both sides. So if I integrate on both sides, see, the derivative of v square should be minus v square should be minus 2, and the derivative of 2v should be plus 2. Now I am going to multiply and divide. See here, this is 2 minus 1, and this is minus v square plus 2v plus 1 into dv is equal to, this is dx by x. And now I'm going to multiply and divide with minus 2. So this is minus 2. And see what happens here. And this is going to become minus half. This is going to become minus half of, this is minus 2v plus 2 into dv value is equal to, this value is minus v square plus 2v plus 1, which is equal to, this is dx by x. This value is dx by x. And if you see, for minus v square, the derivative is minus 2v into dv. And see here, for 2v, the value is 2 into dv. For 1, this value is 0. So here, this can be written as minus half times of log of, this is minus v square plus 2v plus 1. And this value is log x plus the value here is log c. So I am sending this 2 to other side. So this value is going to become minus, this is minus v square plus 2v plus 1 is equal to, this is 2 log x plus this is 2 log c. So here, if I send the whole term to other side, this is going to become log of, this value is minus v square plus 2v plus 1 value plus this is log x square, which is equal to some log c. So 2 into constant is some constant again. So I'm writing as c, and this value is, so I can write this as log a plus log b can be written as log a into b. This is minus v square plus 2v plus 1 into x square is equal to some log c. So if I cancel log on both sides, this is minus v square plus 2v plus 1 into x square is equal to c. So here is a substitution, that is put y is equal to, so y I have kept as v into x, and now this v can be written as, this is y by x. So here v can be written as y by x. So I am transforming this v as y by x. And now see what happens here. This can be written as minus y by x. This is y square by x square plus 2 into, this is y by x plus 1 into x square, which is equal to c. So if I make x square common, this will be minus y square plus 2yx plus this value is x square into this is x square is equal to c. So if I cancel these two, and then what remained here, this is minus v square plus 2xy plus x square is equal to c. And now this is in the form of capital letters. So here our question is in the form of small letters. So I have to transform this one. How I transform this one? See here, I will transform. So capital X can be written as, so here capital X can be written as h minus small k. So this can be written as h minus small k, and capital Y can be transformed as y minus k. So I am shifting. So capital X can be written as, see, capital X can be written as small x minus h. So this is a small x minus h, x minus h. So I'm transforming this in the form of small x minus h, and this is small y. So this is y minus k whole square plus 2 into x minus h into y minus k, and this is again x minus h whole square is equal to 0. And what are the values of h and k? So I'll show you, there are two equations left over here. There are two equations here, that is h plus k minus 2 and minus h. So here this is h plus k. So this is h plus k minus 2 is equal to 0, and minus h plus k plus minus 4 is equal to 0. So if I solve, I'll be getting the values of h and k from this. So here if I solve, so if I cancel these two and see, this will be 2k minus 6 is equal to 0 and k value is equal to 3. If I substitute k is equal to 3 here, so this is k minus 2 is equal to 0, and h is equal to h plus 1 is equal to 0, and h is equal to minus 1. So I got h and k values as minus 1 and minus 3. And now I am going to substitute in place of k as, in place of k as 3. So this is minus of, this is y minus 3 whole square plus 2 times of x minus, what is h here? Minus 1. And y minus, what is k here? This one. Plus this is x minus of minus plus 1 whole square is equal to 0. And this is a general equation. So if I write like this, y minus 3 whole square plus 2 times of x plus 1 into y minus 3 plus x plus 1 whole square is equal to 0. So this is our required general equation. See, let me explain you for one time. See, as it is so easy. So if you see any constants here, observe, you have to uh, identify that it is a non-homogeneous differential equation, and we have to write it in a uniform order as x, y and constant like this, and we have to make a det out of this. If the determinant value not equal to 0, this is the process and this is the substitution here. Small x should be replaced by capital X plus h and small y should be replaced by capital Y plus k, and we have to substitute in this equation. So this is transformed like this. If I separate the variables and constants to one side, so this is going to become a homogeneous differential equation. As you know that for the homogeneous differential equation, there is a substitution, that is put y is equal to vx and dy by dx is equal to v plus x into dv by dx. So if I substitute and solve in the process of homogeneous differential equation, and see here, this will be the answer here, the final answer. And after getting the final answer here, so v should be replaced by y by x, and after replacing and solving, so these are of capital letters and I have to transform, as the question is in the small letters, I have to transform the answer solution in also in the small letters. So here y should be replaced by small y minus k, and x can be replaced as small x minus h. So here how we'll get the values of h and k? So here the constant should be solved, so that we'll be getting h as minus 1 and k as plus 3. And therefore if I substitute here k value and h value, and this will be the final answer. And this is how we have to solve. So we have to transform the non-homogeneous differential equation into the homogeneous differential equation by putting small x is equal to capital X plus h and small y is equal to capital Y plus k. And this is a simple substitution, and in my next video I'll be uploading a different model, that is if determinant equals to 0 and what will be the substitution. So please have a look at my next video also, and it will, both the topics will be very easy, and all each and every problem from the textbook is taught and explained and posted in the playlist. Definitely it will be very helpful. If you really like this video, please raise your thumb, pass it on to your friends and subscribe to this channel. Thank you so much for watching.